Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is implement BCD to 7 segment decoder. So before going into implementation or to draw the logic diagram of BCD to 7 segment decoder, let us see how the LCD display look like. It is having the digit 8 like this. So let us name the segment, each segment. The first segment here is A, this segment is named as B, third C, fourth one D, fifth one E, sixth one F and G. Total 7 segments are there. So it is called as 7 segment decoder. A, B, C, D, E, F, G. Total 7 segments are there. Okay. So let us see how the digit 0 to 9 appears in this display. So when 0 is there, the display looks like this. So here the active segments are, so we are having 3 columns: digit 0, segmented, activated, which are high. Segment activated, and how is the display look like? 0 will look like this. So here what are the segments activated? A, B, C, D, E, F. So I have written as A, B, C, D, E, F. Now coming to 1, the segments activated will be B and C. So we have written B, C. For 2, it will be A, B, C is not there, then D, E and G. Yes, so we have written A, B, E, D, G. Coming to 3, it is appearing like this. So what are the segments activated? A, B, C, D and G. So we have written A, B, C, D, G. Now coming to 4, it will appear like this. So what are the segments activated? B, C, F and G. Now coming to 5, the 5 will look like this. The segments activated are A, C, D, F and G. Coming to 6, it will appear like this. The segments activated are A, C, D, E, F and G. 7 will look like this. The segments activated are A, B and C. 8, all the segments will be activated. So they are A, B, C, D, E, F and G. All the segments are activated. Coming to 9, it will appear like this. The segments activated are A, B, C, D, F and G. A, B, C, D, F and G. So in this way we have seen how each digit will appear in the 7 segment display and found which segments are activated. Based on this, we need to write the truth table. Okay. So now let us see how to write its truth table. So it is a BCD to 7 segment display. Okay. So here using this display, we can display till 0 to 9. We can display the numbers from 0 to 9. Okay. So in the truth table, we will write only up to 0 to 9. Then what about 10 to 15? 10 to 15 will be don't care. Don't care terms. Because it is BCD to 7 segment, the inputs are here 4 variables A, B, C, D. For 4 variables we can have total 16 combinations, that is 0 to 15, but we will be writing this truth table only from 0 to 9, and from 10th onwards it is don't care, so we have not written it. For 0, so let us, what are the digits we can get it? 0 to 9, so we have written 0, 1, 2, 3, 4. Now for the input A, B, C, D, let us write their BCD numbers: 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1. So in this way we have written the total 10 combinations, that is from 0 to 9 in BCD form. Now for 0 digit, for this 0 digit, which segment is activated? We have written it here. For 0, what are the segments activated? We have seen previously: A, B, C, D, E, F. Okay, so these are the segments activated. Which is not activated, put them 0. For 1, the segments activated are B, C, that is all. So activated are kept high 1 and others are left as 0. For 2, the segments activated are A, B, D, E, G. For 3, the segments activated are A, B, C, D and G. For 4, the segments activated are B, C, F and G. For 5, the segments activated are A, C, D, F and G. So these segments activated are kept 1 and not activated are kept as 0. Likewise, we have written for each digit. Let us now see for 9. 9 is 1001 in BCD. Here the segments activated are 1, A, B, C, D, F and G. For 8, all the segments are activated, so all are high. So likewise, we have completed this truth table. So BCD numbers we have written from 0 to 9 and correspondingly which segments are activated. Now we need to write for this A column, where you are getting 1. Suppose in this A column we are getting high at 0, 2, 3, 5, 6, 7, 8, 9. So that we have written it here. So A is high at 0 except 1 and 4, all others are high. So it is written as 0, 2, 3, 5, 6, 7, 8, 9 and the don't care terms will be 10, 11, 12, 13, 14, 15. So these are don't care terms. We have written the truth table from 0 to 9, from 10th onwards it is don't care, because in a 7 segment display we can display up to 9 numbers, 9 digits, numbers not digits. Now for B column where they are high, it is high at 0, 1, 2, 3, 4, 7, 8 and 9. That is written here. B is equal to 0, 1, 2, 3, 4, 7, 8, 9 and don't care terms are 10, 11, 12, 13, 14, 15. Now coming to C, C is high at 0, 1, 3, 0, 1, 3, 4, 5, 6, 7, 8, 9, don't care terms are 10 to 15. D is 1 at 0, 2, 3, 5, 6, 8, 9 plus don't care terms. E is high at 0, 2, 6, 8 plus don't care terms 10, 11, 12, 13, 14, 15, and F is high at 0, 4, 5, 6, 7, 8, 9 plus don't care terms from 10 to 15, and G is high at 2, 3, 4, 5, 6, 8, 9 and don't care terms are 10 to 15. Okay. So, in this way we have written the truth table for BCD to 7 segment. BCD numbers we have taken only from 0 to 9 because we can display the digits 0 to 9 in the 7 segment, and from 10 to 15 they are taken as don't care. So, first we have to write the truth table and write these functions for each segment, that is for A, B, C, D, E, F and G. For each segment we need to get these functions. Now, we will see how to solve them using K-map. So, when you are designing a combinational circuit, the 3 steps are: first you need to write the truth table, second step is to simplify the K-map. For simplifying the K-map, if you are having this list of min terms and don't care terms, you can easily fill the K-maps and simplify. After simplifying the K-maps, based on the expressions obtained, simplified expressions, we can draw the logic diagram of 7 segment BCD to 7 segment display. So, now let us see how to solve the K-map for A, B, C, D, E, F and G. Let us now simplify the K-map for the implementation of 7 segment decoder, BCD to 7 segment decoder. So, you all know what the cell numbering. So, we are going to use a 4 variable K-map because the variables here taken are A, B, C, D. On this side we do the numbering as 0, 0, 0, 1, 1, 0 and then 1, 1. On this side CD 0, 0, 0, 1, 1, 0, 1, 1. So, this is the outer structure of the K-map. Now, let us see inside the cell numbering how they are. It is 0, 1, 2, 3, 4, 5, 6, 7. Then comes 8 here, 8, 9, 10, 11, 12, 13, 14 and 15. This K-map you all have familiar with, which we have already done. So, just to quick review of the 4 variable K-map, I have drawn it here with the cell numbers. Okay, now I am having, we need to draw K-map for A, B, C, D, E, F, G. For each segment we need to simplify the K-map. So, here the list of min terms are given. So, for this we need to fill 1 in that particular cell number, and D means don't care condition, where we need to fill cross sign or X sign. So, if you look at from A to G, all are having don't care terms from 10 to 15, 10 to 15 don't care. So, in all the K-maps, total 7 K-maps I have taken for each segment A, B, C, D. So, if you carefully look at it, all the 10, 11, 12, 13, 14, 15 are X. Here also 10, 11, 12, 13, 14, 15 are X for B segment. For C segment 10, 11, 12, 13, 14, 15 is X, don't care. Coming to D, 10, 11, 12, 13, 14, 15 is don't care terms. Coming to E, 10, 11, 12, 13, 14, 15 are don't care X sign. Coming to F, the don't care terms are 10, 11, 12, 13, 14, 15. So, in these cell numbers we have filled X because they are don't care. Coming to G, again we see in cell number 10, 11, 12, 13, 14 and 15. In this cell numbers we have filled it with X sign or cross sign, which indicates it is don't care conditions. So, we have simplified K map for each segment. Let us now see for A segment. So, A is 1 at 0, 2, 3, 5, 6, 7 and then 8, 9 and remaining this X are don't care, we have already filled it. So, based on this list of min terms and don't care, I have filled the K map like this. Now, if you see, we have to search for maximum group of ones. So, octet, if you see the first, this is one octet, the second octet is this one, and then this is third quad, and from the 4 corners we again form one more quad. So, how many octets are there? 2 octets, 1, 2 and 2 quads. So, let us see now for this octet. For this octet, the common is A. So, we have written A. Now, coming to this octet, the common here is 1. 1 is what? C. So, I have written C. Now, coming to this quad, in this quad, here what is common? B is common. In these two, D is common. So, for this quad, we can write the term BD. Now, coming to 4 corners of ones forming quad, in these 2 rows, what is common? 0 is common. So, it will be B bar. In these 2 columns, what is common? 0. 0 means D bar. So, B bar, D bar. So, the term will come as B bar, D bar. Coming to B segment, we are having 2 quads, 1, 2 and there is one octet also, this 1, 2. So, 1 octet and 2 quads. For this octet, what is common in these 2 rows? In these 2 rows, 0 is common. What is 0? B bar. So, for this octet, overlapping octet, we get the term B bar. For this quad, the term is 0, 0, that is C bar, D bar. So, I written C bar, D bar. For this quad, it is 1, 1, that is CD. So, we got the expression as CD. Coming to C, after filling the ones in the K map, using this list of min terms here for C, we will see the list of min terms and filled it in the K map and then started doing the grouping. So, 1 octet is here and one more octet is here, 2 octets and this one is a third octet. So, 3 octets are present here. So, we get the terms B, C bar, D. For this octet, let us see this octet, what is common? 1 is common. 1 means B. Now, for this octet, we need to look at these 2 rows. What is common? 0. 0 is what? C bar. Now, coming to this octet, in these 2 rows, 1 is common. 1 is D. In these 4 rows, nothing is common. In these 2 columns, 1 is common. So, it is D. Like this, we have simplified all the K maps. So for D we are having one octet here, okay, one quad here, and then one more quad in the four corners of the K map, and one quad is this overlapping quad, okay, and one pair is also possible here. So it's having, for this octet, what is common in these two rows? 1 is common. What is 1? A. So for this octet the term is A. For this quad, what is common? 1 0. 1 0 means CD bar. And now for this corner ones which is making quad, in these two rows what is common? 0. In these two columns what is common? 0. So it will be B bar D bar. So B bar D bar. Now for this overlapping quad, for these two rows what is common? 0. In these two columns what is common? 1. So it will be CD bar. For this pair, in these two rows 1 is common, 1 means B. In this column it is 0 1. So B C bar D, B C bar D. Like this we have got the simplified expression for D. Now coming to E, here we are getting one quad and one more quad by this four corners of 1s. So we are getting the term B bar D bar plus CD bar. Now coming to F, after filling the ones and don't care in the K map, we are getting one octet here. For this octet the term is, in these two rows 1 is common, 1 means A. We are having one quad here. For this quad the term is C bar D bar. One more quad is here. So here it will be 1 is common, in these two columns 0 is common. So it will be B C bar. And here one overlapping quad is there. So here these two rows what is common? 1. In these two columns what is common? 0. So B D bar. So B D bar. Like this we have written for F. Coming to G, we are having one octet. What is the term for this octet? For this octet we need to look at these two rows. Two rows. What is common? 1 is common. 1 means A. Then one quad is possible here. So what is the term here? 1 0. 1 0 means CD bar. Now one more quad is here. So it will be B C bar. B C bar. One overlapping quad here. It will be B bar C. So we got all the expressions of all the segments for A, B, C, D, E, F and G. Now based on the simplified expression we need to draw the logic diagram. Let us now see how to draw the logic diagram. Now we are going to draw the logic diagram of BCD to 7 segment decoder after getting the expression for each segment A, B, C, D, E, F and G after simplifying the K map. So let us now draw for segment A. For segment A the expression we got it as A plus C plus B D plus B bar D bar. So we need to draw 4 input lines A, then connect this A to a NOT gate to get A bar. This is B line, connect it to NOT gate to get B bar. This input line is C, this is C bar, this input line is D, this is D bar. Okay, Okay, like this. So we have taken 4 input lines. Now let us generate for the segment A the function. So we are connecting it to A. A is coming to here, and then C. Then we are getting BD, connecting it to B and D to an AND gate to get BD. The next term is B bar D bar. This is B bar and D bar. We need to darken the connecting points to tell that this particular line is connected to B bar. If you don't darken, it means that this input line is connected to all the input lines here connected to B. So if you can darken it, it will indicate that it is connected to B bar. So after getting the terms BD, B bar, D bar, A and C, give it to OR gate to get the A. Now let us see for B, what is the function we are getting? We got it as B bar. So this is B bar, C bar D, C bar, D bar plus CD, C and D. So we are having 3 terms, CD, C bar, D bar, and this is B bar. All the 3 inputs are given to an OR gate to get the function B. Now for getting C, the function we got it as B plus C bar D, connected to B, C bar, connected to C bar, and then connected to D to an OR gate to get the function C. Now to get the function D, we need to connect it to B bar, D bar, C D, B, C D bar, B C bar D plus B bar C and A. So you know the lines here, it is A bar, B, B bar, C, C bar, D, D bar. Okay, so connect to B bar, B bar, D bar, C, D bar, connect to C, D bar. Next term is B, C bar, D, connect to B, C bar and D, like this. Next connect to B bar C, B bar C. Next connect it to A. So after connecting all these points, we need to give to an OR gate to get the function D. Now let us see how to generate the function E. E is connected to B bar. So this is A bar, B, B bar, C, C bar, D, D bar. Connect to B bar, D bar, B bar, D bar. Next term is C, D bar, C, D bar. Connect, outputs are connected to OR gate to generate the function E. Now for the function F, connected to A, connected to C bar, D bar, B, C bar, B, D bar. All these inputs are given to an OR gate to generate the function F. Now to generate the function G, we need to connect to A. So here it is A bar, B, B bar, C, C bar, D, D bar. So A is connected, B, C bar, B, C bar, B bar, C. Next connected to C, D bar, connected to C, D bar. Okay. B, C bar, B bar C, C, D bar. Connect them to an OR gate to generate the function G. Okay, in this way we can easily implement the BCD to 7 segment decoder. I hope you have understood the class. If you have any queries, you can post them in the comment section. Thank you. Good luck, students.